Hi, my name is Yahya Mateen, and this is my video application for the fellowship.ai program in computer vision tasks. So, a little bit about me. I have done my graduation from the University of Engineering and Technology in Mechatronics, where I focused mostly on artificial intelligence as my elective courses. And in my final year project, I worked with Crescent Bahman, which is a jeans manufacturing company, where the goal of the project was to create an machine learning model that is capable of automatically measuring the sizing parameters of a jeans pant, such as its waist, length, pocket sizes, and so on. Now, why do I want to join fellowship.ai? For first, I have little idea about how companies solve real problems with AI. What is the correct workflow and what type of problems do companies solve? And I think fellowship.ai will give me that opportunity. And second, I want to be surrounded by people who are also passionate about deep learning and machine learning. So now let's move on to the solution. So the challenge was to create a computer vision model that when given an image of a flower, it detects which of the 102 species it belongs to. This is a multi-class image classification problem, and the dataset is available as flowers 102 from the Oxford Visual Geometry group. So first I downloaded the dataset, and the images are compressed in an archive as a tarball, and the labels are available as a mat file. So I wrote a little function that decompresses these images and makes things a little easier to work with, such as renaming the images so that they have a direct correspondence with the labels. So an image that is now named 1.jpg has a label at index 1. Then I create a PyTorch dataset class that basically wraps around these labels and the images, and wrote a transformation function that pre-processes the images in a similar way to what was done for training the ImageNet model. This includes resizing the images to 224 by 224 and normalizing the images with mean and standard deviation. After the pre-processing, this is what an image will look like. Unfortunately, Matplotlib does not support showing the normalization effect because that will push the pixel values below 0. So I denormalize this image, but we can see that the images are now square with padding, and they are now 224 by 224. Then I split the dataset into training, validation, and test sets in the ratio of 50 to 30 to 20. Since the challenge required the use of ResNet 50 with pre-trained weights, I used the PyTorch ResNet 50 with the weights for ImageNet version 2. For the loss, I used cross entropy loss because it is the most natural when performing a multi-class classification problem, where the model outputs scores for all the 102 classes and it compares it with 1 to target class. In the training loop, I trained the model for 20 epoch, and during each loop, it calculates the training loss and the training accuracy and the validation accuracy on the validation set, so we can observe if the model is overfitting or not. After training, I plotted these losses and accuracy plots, and we can see that the model converges very fast within the first 5 epoch, and the training accuracy reaches above 90 within that time, and so does the validation accuracy. And we can also observe that beyond the first 5 epoch, the model continues to improve on the training set and generally also on the validation set. So we can conclude that the model is not overfitting and it is safe to use. For evaluating the model, I calculated the precision, recall, and accuracy on the test set, and we can observe that the precision is 0.91, the recall is 0.91, and the accuracy is also 91%. So we can safely say that the model converged successfully, the training was successful, and there is little generalization error. So that's it, and thank you.